Hi everybody, in this video we are going to discuss about delete at the beginning using C++. But before starting that, I wish to tell a small correction in the code for insert at a given position what we wrote in the previous video, right? So what I have done now is I am using the code as such, and I have added only one insert here. See, other inserts I have commented. So the point that we should understand here is the list is empty when this line is getting executed. I am trying to insert element 10 at the position 1. This will work fine, alright, okay, because you are trying to insert in a empty list at a given position 1. That is perfectly alright, that should work, okay. Yeah, so when you look at it, you see that it's printing 10, that's fine. But if I do a mistake, that is, I am trying to insert at the position 2, right? In an empty list, I am trying to insert at the position 2. Then you see what happens. What happens is you get a segmentation fault, right? Why it happens? Let us see the code. What will happen here? You are giving position as 2 and you are checking here position is 1. No, it will come to the next line and print temp, right? When it is printing temp, you see here it is printing as 0. Sorry, it should not be temp, it should be actually the temp only, yeah, temp only, but it is 0, right? 0 is printed as null here, okay. And then we are having a loop. You see, check the condition for the loop. You are telling counter is 1 less than position is 2. You are checking in the loop whether 1 is less than 1, no. So this loop will not be entered at all and it will come and print here I am outside. That's what we are getting. And then we are creating a node and you are checking whether the node is successful, that's fine. But look at this line number 88. What we are trying to do is we are going to place the next part of the temp, right? What is in the next part of the temp? In the next part of the new node, which is not at all available, right? This new node is available, but when you look at temp, actually it's a null value. You are trying to derefer a null value here, so only we are getting segmentation fault, right? Right. So how to overcome? The simplest option is provide a special case for empty and if the position is not equal to 1, right? So I am going to tell if the list is empty, right, is empty, you can just call it and, right, and position greater than 1, right. In that case what we should do? We should return 0, okay, false. Okay, this is C++. In C++ we can return true and false for booleans, so I am giving false, right. So let us compile the code and run it. You will see that it is not giving segmentation fault and it will not print anything as well because the list is still empty. The insertion operation has failed, right? And I will be making a small change in the algorithm also. So the first step is, as usual, if the position is 1, then you are going to call insert beginning. That will take care of all the cases. If the list is empty, then you are checking whether position is greater than 1. In that case, you will be returning false, indicating that the insertion has failed. Otherwise, you do the usual process, right? Next, we are going to discuss about the delete beginning operation. So what I mean by delete beginning is I want to delete the first node of the linked list, right? So in all the deletion operations you have to check. First thing we have to check is if the list is empty, then what we should do. When you are going to delete, if the list is empty, then you have to return false, okay. That is, you have to tell that the deletion has failed, right. But the point is in all the delete operations we are going to remove the node which we have to delete and we will be returning the value which we deleted as well. So for example, when I tell delete beginning, you are going to remove this node and what is the value here? The value here is 10. So the function should return 10 as well. That's the aim, right? So my return is occupied now, right? I can return only one value in C and C++, my return is occupied. So how can I communicate to the place where this function is called? We can go for global error flags, right? When we are working with global variables, we have to extremely be careful because it can be accessed from anywhere. Already we have discussed about this when we were talking about the array implementation. So we have to be careful with the global error flag, but there is no other option. So we will be declaring it and you will be initializing appropriately. Those things we will discuss during implementation. Okay, and what you will be doing, otherwise I will be having a temporary pointer, okay, and then I will be having a temporary integer in which I have to copy the value of the first node, and then I will be telling head is equal to head next. I will move my head here and I have to remove the node also. For that only we are storing in temp, right? So I hope it's fine. Let us see the algorithm in a formal way. So the input for the function operation is going to be the list, right, in which you are going to perform the delete operation. And the first step what you are doing is you are checking if the list is empty. If the list is empty, then you are returning -1. This is as per algorithm. Yeah, we have to return something. That's the proper way of coding. But I will be setting the global error flag also, that we will do during implementation. And step 2, we will come to step 2 and if the list is not empty, here we are checking, we are declaring a temporary pointer. Okay, so you are declaring a temporary pointer temp and you are going to make it to point to the first node of the linked list. And then you are going to store data in the first node, data which is in the first node in tempint, right? You declare a variable tempint and you are going to store the data in the first node in tempint, and you are going to make head to store the next part of the head. This is the algorithm telling, okay, head should be equal to next part of the head and you will be returning tempint, right? So let us see the implementation in C++, okay, right. So in this new file we are going to add the delete beginning function, and small changes I am going to make. I will uncomment these lines, okay, I will be uncommenting this. And one more thing that I have to do is I have to declare the global error flag. So let me tell delete error flag, okay, this is equal to false. Okay, and then what we are doing is we have to write the delete beginning function. It's a class implementation, so let us make it as a member function. You say the return type is return type is int here, okay, because we have to return the element which we deleted, right, and it will not take any argument. This will be the signature of the function. So let us write it here. We will be telling int list delete beginning, right, and you don't pass any argument, okay. So let us implement the algorithm. What does the algorithm tells? If the list is empty, right? So if is empty, then what we are going to do? We are going to set the delete flag, okay, equal to true, and we will be returning -1. One important thing, -1, why we are returning is we have to return something, because we have mentioned the return type as int, but returning -1 cannot be the indication of failure, because if the linked list by itself contains -1, then there will be a confusion, isn't it? So only we are having a external global error flag, right? One thing that we have to always be careful is whenever we are using global error flag, we have to initialize to whatever value we want. Actually it should be false, right? First you assume that there is no error, and then if there is an error you will make it as true, okay. So you have to initialize in the beginning of the function itself, otherwise there will be side effects. Already we discussed in detail about this in array implementation, okay. So I am just making it a false. If the list is empty, I am making it as true, right? And what we are doing, other things are like we are creating a temporary pointer, okay, and then we are going to declare an integer variable also, right? So this temporary pointer, let us initialize to head, okay. let us initialize to head, and then we will be doing, that is, now we have to store the data in temp int, right? Temp int equal to temp, right, temp data. This should work, right? And what the algorithm tells, head equal to head next, sorry, head equal to head next. That's what the algorithm tells. Move your head to, make your head to store the next part of the head, right? Okay, and I think we have to just return now. Other things are done. Return temp int, right? So this is the code, and let us try to compile it. One thing, I have to compile delete, yes, and you try to execute, right? So what you see here is the list contains, yes, let us go and see the main. First we are inserting 1, then again insert beginning 2. So 2 will go before 1, 2, 1, and then 5, 10. But 10 is inserted at the position 2. So 2, 10, 1, 5. This is what we get because we have called the insert operation in such a way. And then what we are doing, we are calling the delete beginning function. So when you call the delete beginning function, 2 will be removed from the linked list. So you see here deleted element is 2. That's what we are able to see. And then what we are doing is we are printing the list. When we print the list other than 2, all the values are available, right? Okay, so this is how we will implement the delete beginning function. The code will be shared in the GitHub. Thank you.